Section 7.3 Problems. A population has a mean of 33 and a standard deviation of 21. Find the sampling mean and the sampling distribution when n is equal to 100. So for this section, the sampling mean is equal to the mean. So since the mean is 33, the sampling mean is 33, and the sampling distribution is equal to sigma divided by the square root of n. Sigma in this problem is 21 divided by the square root of 100. The square root of 100 is 10, so 21 divided by 10 is 2.1. The second question. A sample size of 5 will be drawn from a normal population with a mean of 60 and a standard deviation of 12. Is it appropriate to use normal distribution? In this case, yes, it is appropriate. Even though the sample size is less than 30, it's only a 5, you can use normal distribution because in the text they say it's a normal population. So then it says find x bar between 50 and 70. So mu sub x is equal to the mean, which is 60. Sigma x is equal to 12 divided by the square root of n, and n in this case is 5. The sample size is 5. The square root of 5 is 2.236, so it's 12 divided by 2.236, which is 5.37. From that you find z. You take x minus mu, so they're saying between 50 and 70. So x bar is 50 first, so 50 minus 60 divided by 5.37, you get a minus 1.86. And from table A2, that turns out to be a 0.0314. So minus 1.86 is here, 1.86. So 0.0314, and then z for the second one you use 70. 70 minus 60 divided by 5.37, so that's a positive 1.86. So again, from the table, a positive 1.86 is right here, 0.9686. So 0.9686, and because this is an in-between problem, this is the one where you subtract the two numbers from the table. So subtracting the two numbers, your answer will be 0.9372. So that would be the answer. The next example, the mean cholesterol level is 202 with a standard deviation of 41. A simple random sample of 110 was chosen. What is the probability that a sample mean level is greater than 210? So this is a greater than problem, so once you look up the number in table A2, you will subtract it from 1 for a greater than problem. So again, we make the same assumptions. The sampling mean mu x is equal to the mean, which is 202. The sampling standard deviation is equal to sigma divided by square root of n, so it's 41 divided by the square root of 110. The square root of 110 is 10.488. So you're taking 41 dividing by 10.488, and that equals 3.91. Do your subtraction problem to calculate z. 210 minus 202 over 3.91 is 2.05. You look up 2.05 in table A2, and that becomes 0.9798. So 2.05 is right here, 0.9798. And because this is a greater than problem, you subtract it from 1, so 1 minus 0.9798 is 0.0202, and that's the probability that a sample mean will be greater than 210. The next problem, would it be unusual for the sample mean to be less than 198? So this is a less than problem. So when I look it up on table A2, that will be my answer, but first I have to calculate z. 198 minus 202 divided by 391, that calculates out to be a minus 1.02. I look that up on the chart and I get 0.1539 because this is a less than problem. That is the probability that I need. However, the question wants to know if it's unusual. In order for an event to be unusual, the probability has to be less than 0.05. So since 0.1539 is not less than 105, this is not an unusual case. So no, this is not true. The next example, a roller coaster ride can hold 60 riders. The maximum weight is 12,000 pounds. Adult men have a mean weight of 194 pounds and a standard deviation of 68 pounds. Adult women have a mean weight of 164 pounds with a standard deviation of 77 pounds. What is the average weight for 60 riders? This is just a question about taking an average of how much weight can go on the roller coaster divided by how many people. So you take 12,000 pounds divided by 60, so the average weight is going to be 200 pounds. The next problem says, if 60 men ride, what is the probability that the maximum weight will be exceeded? Exceeded is a greater than problem, so once you calculate z, you have to look it up on the chart and subtract it from 1. Same categories, the sampling mean distribution is equal to the mean, which is 194. The sampling standard deviation is going to be 68 divided by the square root of 60. That comes out to 8.78. So calculating mean, 200 minus 194 divided by the 878 is 0.68. You look up 0.68 on the chart. When you look that up on the chart, it corresponds to a probability of 0.7517. This is a greater than problem, as I stated before, so I have to subtract that from 1. So 1 minus 0.7517 is 0.2483, and that is the probability that it will be exceeded, the maximum weight will be exceeded. Then they ask a problem for the women. You do the same exact calculation, but you use the women numbers. So the mean for the women was 164. Sigma x is going to be 77 divided by the square root of 60. So when you do that out, let's see, square root of 60 is about 7.746. So that comes out to 9.94. So you're going to be using those numbers, but the exact same calculations as above.